We're going to start today with just a little bit of review. I want you to find the element fluorine on the periodic table. Hopefully that won't be too difficult. The element fluorine is a capital letter F. I do have students who try to make it an FL, but that's actually a different element. It's located way down at the bottom of the periodic table. So this is just an F, and fluorine is located right up here. I'm going to ask you some questions about it and see if you can answer some questions about fluorine. First of all, how many protons does fluorine have? That was from the last chapter, wasn't it? Okay, if you look at the atomic number, it should tell you how many protons fluorine has. Fluorine has an atomic number of 9, so that means it has 9 protons in its nucleus. How many electrons will it have if the atom is neutral? Well, if it's neutral, the number of protons and electrons have to be the same, right? So if it has 9 protons, it's also going to have 9 electrons. What is going to be the most common isotope of fluorine? Now, if you remember, you have to look at the atomic mass for that, and the atomic mass is 19.00, I believe. And so that means the most common isotope is fluorine-19. And so if it's fluorine-19, how many neutrons does it have? Well, if you take 19 and you subtract 9, that's going to give you 10. So it will have 10 neutrons in its most common isotope. How would we classify fluorine? Is it a metal, is it a non-metal, or is it a metalloid? Well, it's to the right side of this heavy stair-step line, so that means that it is a non-metal. What period is it in? Hopefully you said period 2. How many valence electrons does it have? Yeah, valence electrons come from the group number, and it's in group number what? Yeah, it's in group number 17, so it's going to have 7 valence electrons. How many energy levels are its electrons contained in? Well, since it's in period 2, its electrons are going to be in 2 different energy levels. So 2 layers on the outside, like 2 layers of an onion. So you can see just how much you know just by looking at the periodic table about a particular element. Now I'm going to show you today something that's called an electron dot structure. And what this does is it's a way to draw the number of valence electrons that an atom has. So I'm going to start with hydrogen, since it just has 1. Hydrogen just has 1 electron, so I draw the symbol for hydrogen, and I'm just going to put a dot next to it. That's pretty simple, isn't it? If I look at helium, helium has 2 valence electrons. Remember, it's in column 18, but the first energy level is only allowed to hold 2. So helium has 2 valence electrons, and so it's going to look like that. Sort of like drawing a colon after something, okay? Now we're going to go back to lithium over here. Lithium is going to have how many valence electrons? You're right, we're starting to fill the second energy level because the first row is the first energy level, second row is the second energy level. So lithium's going to have 1 valence electron, and so it's going to look like that. Wow, isn't that interesting? Hydrogen and lithium both look the same. What do you suppose sodium looks like? What do you suppose Na looks like? It has 1 valence electron, so yes, you're right, it's going to look exactly the same way. Okay, how about beryllium? Beryllium is Be. How many electrons, valence electrons, does it have? Yeah, it has 2. And it's going to look, it actually looks a lot like helium, but don't let that mess you up because it does not have the structure of a noble gas, because now we're up in the second energy level. So 2 valence electrons. Then when I get to boron, boron has 3. So I'm going to go 1, 2, and now I'm going to put this one up on the top. Carbon has how many? Yeah, carbon has 4. So I'm going to go 1, 2, then I'm going to go 3, and then 4 actually goes over here. The first 2 electrons I pair up, and after that, I'm going to pretend that I actually have a box around my element here like this. And so as you start putting the electrons around it, 2 go on one side, 1 goes on the top, and then 1 goes over here. They don't pair up. And that's for a reason that you'll actually learn when you get to chemistry. I don't want to muddy the waters and make this super complicated at this point. Okay, so carbon has 4, so it's 2, and then 3, 4. How about nitrogen? I'm going to erase his helium because I got him down a little low and he's kind of in the way. Okay, so nitrogen. Nitrogen has how many valence electrons? Yeah, it has 5. So I'm going to go 1, 2, then 1 on the top, 1 on the side, 1 on the bottom. Oxygen has how many? Oxygen has 6. So I'm going to go 1, 2, 3, 4, 5. Well, now I've got all the sides of my box full, so now I'm going to go up and I'm going to start pairing them again up here. So there's oxygen. Fluorine has how many? Yep, it has 7. So I'm going to go 1, 2, pair the first 2, 3, 4, 5. Now I'm going to go back and pair these. 6, 7. And then finally in that row, neon has 8 valence electrons, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. And so if you have a noble gas, they're going to have 8 valence electrons, so they're going to have 2 on each side of their symbol there. Now, the important thing to understand is that once you can do this for the first row, you can do it for anything in that column. So if I had sulfur, for example, sulfur's right under oxygen. It has 6. So sulfur is going to look exactly the same. 1, 2, 3, 4, 5, 6. Okay? So that is electron dot structures, and the reason I'm teaching you that is because that is going to help us understand how atoms start to bond to each other, which is the basis for how all chemical reactions happen.